So in this problem, a student drops a ball from a window 3.5 meters above the sidewalk bed. So let me go over the word drops. When it says drops, this implies that the initial velocity in the y direction is going to be 0 meters per second. And when it says drop from a window 3.5 meters above the sidewalk, well, let me go ahead and draw a window and let this be the sidewalk. So it drops from here downward. That means that this here is a y displacement then. And if we let this be our origin, that means that it's going to drop below 3.5 meters. So its y displacement then is going to be negative 3.5 meters instead of a positive 3.5 meters. How fast, or in other words, what is its final velocity, is it moving when it hits the sidewalk bed? So let me go ahead and write my givens. First, we know that the initial velocity in the y direction is going to be 0 meters per second because it's dropped. Next, we know the y displacement, and since it's falling down, we're going to let it be negative. So it's negative 3.5 meters. And because it's in free fall, because the only force that acts upon it is gravity, and it's moving only in the y direction, its acceleration is going to be negative 9.8 meters per second squared then. And finally, my unknown is final velocity. Now with my givens, I'm going to go ahead and figure out which kinematic equation to use. First, I need the y displacement then. So I'm going to look at my 4 kinematic equations and eliminate which one I don't need. This equation has y displacement. This one doesn't, so I'll go ahead and eliminate this one. This one has it, and this equation has it. Next, I need initial velocity, and all 4 kinematic equations all have initial velocity. Next, I need acceleration. So this equation does not have acceleration anywhere, so I'll cross this one out. This one has acceleration here, and this equation has acceleration here. And finally, I need final velocity then. So if I look at this equation, final velocity is 9 here, but final velocity is here. So it looks like I will be using the 4th kinematic equation to solve for my unknown. The next step, I'm going to solve for my unknown, so I'll rewrite my equation again. Final velocity square is equal to the initial velocity square plus 2 times acceleration times the y displacement then. Now, solving for my unknown, I need the final velocity isolated. So if I rewrite this one more time, the only thing I can do to this equation is get rid of the square. So what I'm going to do is square root both sides of the equation. So now if I take the square root of this, it will be final velocity. And then this over here on the right side will just stay the same. So initial velocity square plus 2 times acceleration times change in the y displacement. And remember, whenever you take the square root, you have to decide, is it going to be a positive or negative value when you get your answer. So moving on, final velocity equals the square root of initial velocity square plus 2 times acceleration times y displacement. Let me go ahead and plug in my values. So if I plug in initial velocity, that was a 0 square plus 2 times the acceleration, which is negative 9.8, times the y displacement, which is negative 3.5, positive or negative. So again, let me go ahead and simplify this equation. So the zeros drop out. 2 times negative 9.8 times the negative 3.5. That becomes a positive 68.6. And then the next step, I'll square root 68.6. I should get 8.2 8.283. Now, because the ball is dropping, that means that you're going to take the negative sign because it's going in the downward direction. And when it's going in the downward direction, we're going to pick the negative sign. So your answer is going to be a negative 8.283. And the units for velocity is always going to be meters per second. So with my final velocity answer to be a negative 8.283 meters per second, we're going to double check our answer. First, check the sign. Because the object is going in a downward direction, that means you're going to have a negative sign. Second, you want to check the magnitude of the object. It's not going too small, it's not going too fast. 8.283 does seem like a reasonable velocity for the object to fall. And finally, you want to check your units. For velocity, our units should be meters per second.